Hi, I'm Miss Hall, and this is Lesson 88, Using the Normal Distribution. We're going to start by reviewing Lesson 87, the big idea of areas under a normal curve. A normal distribution with mean mu and standard deviation sigma has these properties. The total area under the related normal curve is 1. About 68% of the area lies within 1 standard deviation of the mean. The mean is mu, so mu plus sigma or mu minus sigma, that's 1 standard deviation above and 1 below the mean. About 95% of the area lies within 2 standard deviations of the mean. So we can go 2 sigma above mu or 2 sigma below mu, are 2 standard deviations above and below the mean. And then about 99.7% of the area lies within 3 standard deviations of the mean. So mu plus 3 sigma, and mu minus 3 sigma. And then we have graphs. I would recommend memorizing 68, 95, 99.7. Once you know those 3 values, you can split them in half to find each individual area's percent. This is probably too much to memorize when you need to recall it in June. So memorize the 68, 95, 99.7, and then be able to calculate all of these values individually. Example 1, finding a normal probability. A normal distribution has mean mu and a standard deviation sigma. An x value is randomly selected from the distribution. Find the probability that this x value is between mu minus 2 sigma and mu. It helps me to have a visual. So mu is the mean, right? And sigma is a standard deviation. So we have mu plus sigma is 1 standard deviation, mu plus 2 sigma is 2, mu plus 3 sigma is 3 standard deviations above the mean. We can do the same thing below the mean. And this time it is mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. Okay. So we want to know that x is between mu minus 2 sigma and mu. So we need to figure out what percent of the data lies in those 2 blocks. So it's 1 standard deviation below. Well, actually, it's 2 standard deviations below. I have memorized that 1 standard deviation, that's 68% of the data lies within 1 standard deviation. So if I divide that in half, 34% of the data is in the first standard deviation below the mean. So it's 34%. And then we have 95% of the data is within 2 standard deviations of the mean. So let me find the difference of 95 minus 68. 8, that's 15, 7. So that's 27. I'm going to have to divide it in 2 to find those 2 separate blocks. So 27 divided by 2 is 13.5. So this is 13.5%. Of the data lies in that block. And then I can add that together. So the answer is 47.5% of the data lies in those 2 blocks. In other words, the probability that x is between mu minus 2 sigma and mu is 0.475 which is equal to 47.5% of the data. Example 2, interpreting normally distributed data. The scores for a state's peace officer standards and training tests are normally distributed with a mean of 55 and a standard deviation of 12. The test scores range from 0 to 100. About what percent of the people taking the test have scores between 43 and 67? Let me draw a graph of this normally distributed data. The mean score, or the mu, is 55. So I can label that here, mu, and the standard deviation, or sigma, is 12. So now I can say 55 plus 12 is 67, plus 12 is 79, plus 12 is 91. And I can do the same on the other side. So I can take 55 minus 12 is 43, minus 12 is 31, minus 12 is 19. Anything else I want to label? Not yet. Okay. About what percent of the people taking the test have scores between 43 and 67? 43 and 67. Well, that is within one standard deviation of the mean, and that is 68% of the scores lie within one standard deviation of the mean. B, an agency in the state will only hire applicants with test scores of 67 or greater. About what percent of the people have test scores that make them eligible to be hired by the agency? So for B, we only want to see what percent of people lie in this green part of the graph. A couple ways to do it. You could calculate these individual probabilities, or refer to the graph on the front side. I am instead going to stick with what I know really well is that 68%, and that either side of the mean is 34%. And I'm going to use that to my advantage. Okay. The mean, half the data lies on either side of the mean. So there is 50% of the data to the left of 55, and then there's 34% of the data to the right before I get to 67. So instead of adding these three individual percents, I'm just going to take 50% plus 34%, which is 84%. And I know that's the wrong side of the information. That's the area under this part of the curve. So I'm going to take 100 minus 84 to get 16%. My final answer. Again, you could have added up. This is 13.5 plus 2.35 plus 0.15. But I'm not going to memorize that. Instead, I'm going to stick to that 68% and use that knowledge to help me answer this problem.